Welcome back, everybody. We just got done talking about how we can use the line integrals with respect to individual variables with a vector field. Let's take a look at doing work along a path. So recall in Calc 2 or physics, if you want to do the work from moving a particle from or something from A to B with the force being f of x, we could do the integral of A to B, f of x dx. That's our work. Previously this semester, we did the same thing with dot product, F being the force in a particular direction, D being the distance or the line segment from P to Q, or the vector from P to Q, the starting point to the end point. How do we kick that up when we've got like a force field, not just a force, but a force field, like gravity or electrostatic force? I hate force field, sounds like a, you know, like what protects the Starship Enterprise. I don't know. I wish they didn't use that. A field of force. How about that? There's a continuous field of force like gravity or electrostatic force. How do we calculate work done by moving something through the field of force? So if you want to read through the math, we can. It boils down much along the same things as doing the line integral, but for small enough delta SK, we're really just pushing in the tangential direction. The force is in the tangential direction, or it's approximately in the tangential direction. So we're going to do F dotted with T. As you'll see in the next page. F dot dr is going to turn into F dotting with T. So the force in the tangential direction along that arc length. And the reason why we can use that is because it's for approximately the same thing for the force along the curve is in the direction of the tangential, especially as ds goes to 0, the length goes to 0. So that's what we're doing. Work is going to be force dotted with T. Recall that T is r prime over the magnitude of r prime. So we're doing the line integral with respect to the arc length of the tangential component of the force, which is how much is pushing us forward in that curve. We've got F dot T. So I'm just plugging in what we know with R of T and our tangential vector being related to R. So F of RT, then T is R prime over the magnitude of R prime. ds is r prime dt. Notice the norms cancel out from ds and our tangent vector, and we get f of r dotted with dr. So work is calculating work in a vector field is very much a dot product of a line integral with dr dt. Not a line integral, it's the work along a line following the work of doing something in a field of force following a path along the line or the curve is approximated or calculated with this. So F dot dr is F dot T ds when we're working with the force or something like work. And recall that orientation matters. In this case, we're not doing ds anymore. We're doing each component x, y, z. So orientation matters. Switching direction matters. I don't have a problem worked out with work. There's plenty in class. We'll do something in class with it. Peace.